chemical sensors, you have gas sensors, fire protection sensors, widely distributed. Can you use the wind to power this? Yes, we can use this tongue shape. This is a polymer. When wind go through this one, this tongue oscillates. You see, early day we show this one. You see, when you blow this, the wind go through here. So we make this a few units stacked together, and then when wind go through here, the power generated here can be integrated and send a signal wireless. We already achieve at a wind speed of about 4.5 meters and 2.5 kilometers away. We send a signal once every 18 minutes at a radio frequency. So we can do wireless communication here. You can imagine if you have water quality tracking, environmental monitoring, many monitoring, you make a map across the field, use solar power technology here. You can prevent nature disaster. You can put in the ocean, use the floating water to power a light pole. You can also use this one for chemical sensors here. You can do this one, use the floating waters to detect chemistry of the water and send a signal wireless to the side here. You can also use this one for a variety of earthquake predictions, landsliding predictions. This is the landsliding prediction here. In some areas, landsliding occurs at midnight. Nobody knows about it, but you can do this as a warning system. Use our TNG as a trigger, as a sensor. Solar power sensor is another application of TNG. For example, when you play ping pong ball, if the ping pong ball strike the table, you can strike on the top edge is a valid ball, but if you strike on the side of the ping pong table, is an invalid ball. Let me show this one. You can see our people demonstrate. You see the ping pong ball strike here is a valid ball. We detect the signal, and then if the ping pong ball just touch the side rim, you get another signal which is not an invalid ball here. So basically for sports, TNG has a huge application. And this is just used because you can use any material you want, any structure you want for sports, for volleyball, basketball, for tennis, whatever. You can use it as a sensor and a trigger. Okay, this is for typing. You make a keyboard to record your typing. When you type a text, the way not only record the alphabet you type, but also record the way you type, the time interval between the two and the difference between the two. And you see this one, we can identify who typed it. Who typed it? So not only just the input information is correct, but who typed it? This is our people demonstrate. I have 6 figures. This is 6 figures. So you can use a finger put in. The computer recognize who typed it in. The reason they recognize is use the smart keyboard developed based on TNG. If you go to library, you have 1,000 books. If somebody touch a book, you don't know. Okay. Even use a video, it's very hard to surveil such a large number. But we can, for each book, we can build a TNG here. And when anybody touches this one, there's a signal sent to the receiver. We can know which book was touched. Let me show you this one. So you see, this book is being removed. Another book is moved. So this is for solar-powered sensors here. This is can really use for documentation tracking, because the reason, even you have this over there, somebody touch it, you never know. Even use a battery to charge it, the battery way gone without power, because maintains the power is very difficult and resource consuming. And we can make this one for robotic, soft robotics. Remember, soft robotics need power, need this sensors here. You need to make, so our TNG can make the soft robotics have a very unique sensor. Okay. For the blood pressure measurement, if you put on this one, the risk here, you not only measure the pulse, but you also measure blood pressure. And you see, many people used to wear this iWatch and thing. I don't see very many get any popular, because I had one. I only wear it for 2 weeks. I just get rid of it. It's always need to charge. You always have some other things that didn't measure it accurately, so I didn't wear it at all. So this one, you can see that these things can be measured your pulse. This is for medical care. Is the care. It's not only just the pulse, number of pulse, but also the pressure, blood pressure. And robotics. You use a paper-based hearing aid put in robotics. You can have a microphone as a music recorder, and then you play back. See what it is. Look, let me show you if you can hear me. Can you hear the music? I hope you can hear music. Okay, this is the traditional music here. Use this as a microphone, paper-based TNG as a microphone to record it. Then you play back. This is the playback without any digital filtering, any other the data processing, just a native play. You can see 90% of accuracy of sounds has been preserved. This is not only for that, can be for robotics communication. A human with robotic communication. Remember, use a paper-based TNG has a microphone, which you never have been able to do before. Okay, voice recognition. They didn't recognize because this is the how you come over. You can see voice recognition utilize our TNG-based microphone, which is very interesting here. Okay, blue energy. What is blue energy? Energy in the ocean is huge. Just the coast area around the globe is 75 terawatt. This is 4 times of the energy power the whole world. But having such energy is extraordinarily difficult, expensive, difficult environment, high cost, and corrosions are very difficult to operate and low efficiency because you rely on classical technology. How about our new technology? So how do we do it? So we have not utilized energy offered by the ocean. So how do we do it? So we make a sphere and a sphere. Inside the sphere, we have another sphere. So if in the water wave, if this wobbling back and forth, you can see wobbling back and forth, power generate. The reason because this ball rolling back and forth, contact separation, get a power generation here. So this is a way to produce power. Just one ball. Okay. If you have, how do you see the way because the trickling frequency is slow, but how can you enhance the trickling efficiency? We use this pendulum structure. So if striking this once, they can oscillate 80 seconds without stop. Without this one, we can already achieve 28% of energy conversion efficiency, which is far beyond whatever any existing technology for mechanical energy conversion. You can see this in the water, and this is the light wind. You can have the heavy wind, but for light wind, you cannot do it. But our technology can do it. So basically offer a brand new approach, a groundbreaking technology for harvesting wind energy and water wave energy, complete different thinking. If you put this one, regardless of the depth of the ocean, regardless of the low frequency, we can do it. We can do it. So how do we do it? We put on the surface, you can see in the water, each is floating, and we can put it on the surface of water, make it networking. 3D networking, you can harvest energy. This can offer a brand new approach for harvest energy from wind, from water wave, from anything, regardless of depth, regardless of distance, it make it possible. So this one can be integrated. So this is called blue energy. So fundamental, what's the difference? Always I emphasize fundamental things. You have to be physically different. This is the electromagnetic generator. The power output is the square of the frequency. Use magnets, coils. This is the traditional technology. You cannot change it. Over 180 years. What we do is here is linear with frequency. So therefore, we use polymer materials, organic materials for mechanical energy harvesting. Fundamental difference is that low frequency electromagnetic generator has no output, very little. But ours is many times higher. So basically, this is the killer application. We can do the things traditional technology cannot do. So therefore, at low frequency, we have the unbeatable advantage in comparison to the classical technology. So we are not talking about replacement, but we can do things classical technology cannot do. Okay, so this is the physical difference here. Then we make this one. You can see this is the power generator here. You can see in the water. Okay, you can put it in the water density. You can simulate in the water flow here. So all this experiment being carried out. So very interesting, very different from classical way to do things. Okay, so the way I present to you is of a new approach for this one. So we hope for this to offer a new way for future of world energy. When we run on fossil energy, what are we going to do? Okay, I think as long as there's wind around in the ocean, there's vast energy we can harvest. So if we can expand this technology, we'll have provided an unprecedented approach for solve the world energy at large. Okay, so I think my talk is short because only 35 minutes. I cannot talk very much in detail, but I hope to give you a brief review. First one, what's the fundamental of content electrification? We have many papers in this regard, which is the question remain for 2,600 years old. Very old physics phenomena, but not clearly understood until now. So therefore, it has quantum mechanical electron transition there. So this is the first thing I present. The second one, what's the difference of our TNG compared to classical technology? Is Maxwell's displacement current, is not the traditional conduction current. That's the difference. So people always ask me, say, tell me why you still call nano generator. So when we propose nano generator, we use nano wires. We use nano wires as the source for power. If you can say you have a nano wires, use the EFM tip to trick it, you get power. We call nano generator. This was 2005, 2006. But that time we did not understand the fundamentals of physics of the power generation for our technology. Until recently, we understood it is Maxwell's displacement current. Therefore, so nano generator is a field that utilizes Maxwell displacement current as the driving force for converting random, low quality, distributed mechanical energy to electrical power. So that's the definition of nano generator. You can use nano materials for better performance, but you don't have to. Okay, so therefore, just like a battery, you never call nano battery because battery was created at large. But now use nano materials. Why don't you call nano battery? It's basically the principle of the battery remains the same. You just use nano material for better performance. I showed 4 major applications: micro nano power source, solar power sensor. Remember, this one have a lot of commercial opportunity, and also large scale blue energy. We have an idea for solar world energy at large, and of course, this have a long way to go. As now around the globe, have 54 countries and regions, 700 units, 4,300 scientists working in this field. This is based on the SCA data search. So there's a big field being formed. As we do nano for many years, nano is beautiful, but most importantly, nano has to be useful. We cannot just carry on beautiful. Yes, it's beautiful, but it has to solve the world problem to some extent. And we need must think in that regard, because nano has been around for 30 years or so. I remember it's around 1990s. When I was graduate in 1987, it was not called nano. That can call small particle. Until like a carbon nanotube is small, they call nano becomes more fashion. It's about 30 years or so. So now we need to think, what's the major problem you can solve? What are the unique things you can do? If you continue to call this nano for another 20 years, nobody will be care about that time we call nano or not. Let's show it works for us. It can solve real problem. I think for the whole community, micro nano community, we have to keep this in mind all the time. So nano generator have 4 major applications: micro nano power source, solar power sensors, a sensor which may not need the energy to work, blue energy at large, lastly high voltage for that. So I think there's a lot of possibility ahead of us, and I hope many young people can join this field from material science, chemistry, physics, electrical engineering, mechanical engineering, even biological engineering. It's a diverse field, need everybody's input and contribution. Thank you very much for the invitation, and I hope I give you a brief overview what we have been doing for the last few years. Thank you.
Thank you, Professor Wang, and I really enjoyed a marvelous talk today. And actually, we've got some questions raised from different platforms, and we are collecting these questions, and we are also expecting more questions. Now we we have some question here, so I'd like to show. I'll just pick up a few to pass it to Professor Wang. So the first question is there any limitation for the future application of TNG and blue energy?
Every technology has its advantage and disadvantage. Our major challenge faced now is the durability and robustness of the TNG, because this uses the organic materials. Sometimes you can use inorganic materials, but the system may not as stable as the classic electromagnetic generator we use now. So we are working right now how to improve the durability and stability problem. So that's the number one challenge we remain. For micro small energy, we always face the needs of every increased power density and power. So therefore, people always need more power, more power. So we are trying very hard to enhance the efficiency for the harvesting. I will also integrate TNG with other energy harvest technology, like for example, like a solar cell into a hybrid cell. For the large scale blue energy, we just at the very beginning, because this one need a very large project to do it. We currently don't have that project to do it. We just test in a lab, but we need to experiment in a real environment, because then you can work on a corrosion problem, the communications, integration of powers between one unit with the other ones, and then how the power be effectively utilized. So this is a big field to be developed in the next 5 to 10 years or so.
Okay, perfect. So the next question is about the environment. Okay, everybody talks about energy and environment. So the second question is about environment. Someone asked, will the application of this blue energy affect the climate, as it involves some interaction with the ocean, like the tidal movement? So there any effect is there?
Oh yeah, okay. So let me tell two parts, because the classical technology use coal and oil, which could bring a lot of climate change, because majorly the ozone layer damage, as well as carbon monoxide emission in our carbon dioxide emission around the globe. So global warming is happening, and because we burn a lot of oil and coal, where's the heat go? In our environment, it cannot be dissipated in space that much. So global warming is happening. So now, if you use the ocean energy, which you don't need to burn this coal and oil every day, you can save a lot for global warming. Number one. Number two, you concerned about the marine life. You see, when you build an ocean, you don't need to build a network, cover a large area, leave no space for animal to live. You can build a patch. Between the patch, have a separation, give animal enough room to live. Then so how large the area you need to solve the water energy? I did a theoretical estimation. For an area of 400 kilometer by 400 kilometer, roughly speaking, is the size of the state of Georgia, or the size of Shandong province. 10 meters of depth of water, you make into 3D. The total output power is the world total power consumption. Then you say, how large is 400 by 400 kilometer area on the ocean? Is 3 parts of 10,000. 3 parts of 10,000 of the surface area of the Earth. Very little bit. You can build this one in an area that no ship, no marine, not very much human activity, very complicated geographic configurations. That's good enough. So therefore, it have some environmental impact, but not as big as the fossil energy cost to us as we are now.
Okay. Third question is, yes, everyone knows that everybody pay attention to the utilization of sustainable energies, and we have a pretty mature system to incorporate the energy, electricity from the wind, from the solar, to get into the grid. So what do you think is the challenge for TNG to get energy into the grid?
The major challenge for solar and wind is instability. I personally believe it's a good supplement to local utilization. But if you use solar and wind energy to grid, it's caused a lot of instability in the grid and a risk. So that's why there's a limitation for both. That's